Hey, grade sevens, we are starting the last chapter of the textbook and of the year, which is pretty exciting. We're just going to be doing it in just two lessons so that we are done this unit before that last week of the year. So it's going to go sort of quick, but it's pretty straightforward, and I think most of you will get it. So for these first two sections, section 12.1 and 12.2 in your textbook, we are looking at median, mode, and mean. So these three M words. And these are all measures, another M, measures of central tendency. So all three of these, median, mode, and mean, they're all described as a measure of central tendency. Now, a measure of central tendency is a value, so a number that we find, that represents the center of a set of data. So it can be mean, median, or mode. So all three of those are called a measure of central tendency. So there's those three different ones we're looking at. And it's a number, a value that can represent the center or the middle of a set of data. And so there's sort of these three different ways that we can look at these. So we'll go through some examples to demonstrate. So median. The median is the middle. So you remember that the word median has a D sort of in the middle, and so does the word middle have a D. So hopefully you can remember that those two are the same. So median means middle. So the middle number in a set of data, so when you have a group of numbers, after the data has been arranged in order. Okay, so you have to arrange the data in order from least to greatest, and then you can find what the middle number is, which we call the median. So in this example, the Edmonton Oilers, they won 7 out of 10 games 1 month. As a team, they scored the following number of goals in these 10 games. So they scored 5 goals, then 4 goals, then 3 goals, then 2 goals, then only 1. Probably lost that game. Then 5, then 3, then 3, then 7, then 3. Okay? So those are the 10 games. Those are the 10, how many goals they scored in each of those games. So what is the median number of goals scored? Or in this set of numbers, what is the middle number? So what we do is we take all the numbers and we arrange them in order from least to greatest. So we find the least one. Okay, there's the 1. I'm just going to cross it out to make sure that I've written it down here. 1. Okay, 2 is next. 2. Then there's 3. Oh, there's another 3. Another 3. Another 3, and I cross them out up top in there. I'm just doing that just so that I can make sure that I've gotten every number. You don't have to do that, and sometimes if you're working on your textbook, please don't cross out the numbers or rewrite it yourself on your own page. Okay, so after 3, here's 1, 4, and then I have 2, 5, so 5 and 5. Oops, common up 55, and then 7. Okay. So now I look, and I'm going to see what the middle number is. So if I sort of count from each side, so I'm going to go in here and count in here, go to the next number, go to the next number, and I'm going to sort of work my way. If I could draw, can I draw with 2? I'm going to work my way to the middle. Yes, here we go. Okay, so when I worked my way to the middle, I actually came to 2 numbers, because there isn't a number in between these. There's not another data, right? There's not another, we don't have 11. So if we had an odd number of numbers, there would be 1 single number right in the middle with another set of numbers on each side. As it is, there's 2 3s. So this is something important to remember, is that sometimes there's going to be these 2 numbers in the middle, But then you just find, well, what would the number be in between them? In this case, since they're both 3s, the median in the middle, we would say, is equal to 3. Okay? So that's median. You're finding the middle in your set of numbers when they're arranged in order. Okay, mode. Mode is the most. You'll recognize that both mode starts with MO and most starts with MO. So hopefully you can remember that mode is the most frequently occurring number in the set of data. So there can be 0 modes. Sometimes there's no modes, or there's maybe going to be 1 mode, or there actually can be more than 1, but usually you don't look at more than 2. So for example, looking over here, the mode of 3, 5, 7, 7, and 9 is 7, because 7 occurs twice and no other number occurs more than once. Okay, so that's the most occurring number, is 7. So the modes of 2, 2, 4, 6, 6, and 8, and 11 are, there's 2 modes, 2 because there's 2 2s, there's also 2 6s, and so the modes are 2 and 6. Okay, so there can be 2 modes there. The data of 1, 3, 4, and 5 has no mode because all of those numbers are different. So there's not 1 or 2 that occurs more than the rest. Okay, so mode is a bit of an interesting one because while it is still a measure of central tendency, the mode is not always necessarily near the center of the group of numbers when you look at it in other ways. But it is still important to see sometimes that that number occurs the most often. So let's look at the mode for the same 10 Oilers game. We found the median, which we saw was 3. And in this case, let's look and see what the mode is. Well, there's 1, 2, 3, 4 3s, and so the mode is also 3. That isn't always the case. In this case, the mode and the median were the same. Okay, let's do a couple examples for mode and median. So find the modes and medians of each set of values. So A, let's do mode first, because mode, you don't have to arrange everything. So mode for A, well, there are 2 4s, so the mode is 4. And then for median, let's rearrange these. So 2 is the lowest number, and then there's 2 4s. So the 2 and the 4s I've written down, and then there's a 6, and then a 9. So what is the number in the middle? Well, I can start from each side maybe and sort of go back. Oh, okay, I met here in the middle. So 4, the median is 4. Okay. B, the mode. Well, we have 11, 5, 8, 11, and 10. So there's 2 11s. There's only 1 of everything else, so the mode would be 11. The median, I would write down these numbers in order. 5, 8, then 10, and then 2 11s. Again, I'm seeing, okay, the 10 is in the middle here. There's 2 on each side of it. So the median is 10. For C, the mode is the most occurring one. Okay, I have 4, 5, 8, 5, 5, 8, 5, 7. Okay, when I read through it, it sounds like 5 is there the most. I can count. I have 1, 2, 3, 4 5s. Okay, so 5 is definitely the most occurring number in that set. My median is, well, let's rearrange these from least to greatest. So 4 is the lowest number in that set. And then I seen that I already have 4 5s, so I'm going to write those 5, 5, 5, 5. And then after that, do I have a 6? No, I do have a 7. And then I have 2 8s. Okay, and so the median, let's look here. Okay, there's 2 numbers that are in the middle, 5 and 5, but the number that would be in between those essentially is 5. So it's the answer would just be 5, we could say. We don't need to say 5 and 5. And D, the mode, which is the most occurring one, 14, 6, 14, 8, 10, 6, 10, 12. Okay, I think I said a couple numbers twice. So there was, I said 14 twice, I did say 6 twice, and I said 10 twice. Okay, and then 8 and 12 are just there once. So the modes, I could say there's 3. There's 6, 10, and 14. And the thing with mode is that if there had been, let's say, another 12 here, well then sure, there's then 4 numbers that all have the most, but there's only 1 number that has 1 least. In that case, you could still potentially say that there's 4 modes, but that information is not very useful. With mode, you're trying to see if there's 1 number that stands out as occurring the most frequently. And in this case, yes, there's 3 that happen twice, so they are occurring the most frequently. But when there is lots of modes and they all have a small number each, that doesn't give you very much information, or it's not as useful. Okay, so but those are the modes, and then the median, we'd have to rewrite this in order. And so 6 is the lowest, and we have 2 of them. So 6, 6. No 7s, then we have an 8. And no 9s, then we have a 10. No 11. Oh, we have 2 10s. That's why it's sometimes good to cross out the ones that you've written down. And then I have a 12, and then 2 14s. Okay, so in the middle, going finding the center. Okay, so since there's 8 numbers total, there's going to be 2 in the middle. It's 10 and 10. Between those would be 10. So the median is 10. Okay, hopefully that makes sense. Mode and median, pretty straightforward. Just got to look at the numbers. Not as much math that needs to be done. Just want to quickly look at these other ways of showing data, which is often called a tally chart. So in this case, instead of just showing a long list, when you know that there's only certain numbers that are going to appear in it, you can make a tally of how many times each of those numbers occur. In this case, the tally, they actually show the numbers. Sometimes, instead of that, they'll show an actual, like, the sort of tally counting up by 5s. The tally charts will often show that way. It's actually sort of often simpler when they show it that way, because then you don't get as confused which one is your numbers and which one is your tally. Okay, so it would sometimes look like that with all the ticks, counting them off. So the question is, find the mode and the median prices of the baseball caps sold in the last week. So here are the baseball cap prices. So there's baseball caps that cost $7, $9, $10, and $12. And then this list over here, the number of sales, that tells us how many of each of those prices caps were sold. Okay, so if we wanted to show this as a list, we actually could. There are 5, I'm just going to erase these for now. There are 5 $7 caps sold. So since we're looking at the mode and median of the prices, there'd be 5 $7 caps sold, 7, 7, 7, 7. I could rewrite this tally chart out as a list. Then there were 5 $9 caps sold, so 9, 9, 9, 9, 9. 6 $10 caps, 10, 10, 10, 10, 10, 10. And then 4 $12 caps, 12, 12, 12, 12. Okay, so I'm writing this out, not because you necessarily have to when you're given a tally chart. It can be useful to write it out, but just to show that a tally chart is a different way that we can show a set of data, just like this list of numbers, and it's useful for when you have a certain set of numbers that are occurring often. So in this case, only 7, 9, 10, and 12 are occurring because those are the costs of the baseball caps, and we can easily see how many times they're each showing up here. So if we're trying to find the mode for this, when we have a tally chart, it's actually really easy because we can just look at our tally side, the number of each, and we can just see, oh, right here, 6 is the highest number. That doesn't mean that 6 is the mode, it means that 10 occurs 6 times. So that means that 10 occurs the most times, it occurs 6 times, and so our mode is 10. If we were to make our list, we could see that easily as well because we can count 10 or 6 tens right here. Okay, so the thing with tally charts, you have to be careful, especially when these are written as numbers and not as ticks, to not confuse these numbers with numbers that are in your set of data. They just are showing how many times each of these numbers on the left appear. Okay, so we can find our mode very easily when you have a tally chart. And then, whoops, not our mean, our median is the middle number. Okay, so we could use our list. We know how to do that, counting from each side, finding the middle. We could also look into our chart here and see how many baseball caps were sold. So there's 5, 10, plus 6 is 16, plus 4 is 20. And so when we divide that by 2, we have 10, and so we know we're going to have 10 numbers on one side, 10 numbers on another. Since it's an even number, there's going to be 2 numbers in the middle. It's going to be the 10th number and actually the 11th number that will be in the middle. And so when we can either look and count on here. So where's the 10th number? Well, there's 5 here, and then the 10th number would be a 9. And then the 11th number would actually be the first 10 written down, so 9 and 10. Maybe that was a bit confusing. It's sometimes hard to see on a tally chart, and that's why it can be good to write the numbers down. And then you can count your way in. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, and then in the middle, in between 9 and 10 would be our median. Okay, so now we don't like to write that we have 2 medians, 9 and 10. We want to say, well, what would be in between 9 and 10? Well, what's in the middle of 9 and 10? 9.5. Okay, so hopefully that makes some sense. Median and mode, mostly mode is the most occurring one, median is the middle. Okay, so these are the key ideas from your textbook. Mode is the most frequently occurring number. If no number repeats, there is no mode. It's okay if there's no mode. There can be more than one mode. So in 1, 1, 2, 2, and 3, there's 2 modes. There's 1 and 2. We call that bimodal. Bi meaning 2, like bicycle, 2 wheels. Bimodal means 2 modes. So the median is the middle value, median middle, in a set of data after the numbers have been arranged in order. So in this case, 1, 2, 3, 4, and 5, the 3 is in the middle, so it's the median. Now if there's an even number of values, and the median is the value halfway between the 2 middle values. So when there's 6 numbers here, 1, 2, 3, 4, 5, 6, there's 2 numbers that are in the middle, and so we're looking for what would be in between them. So in this case, the median is the value halfway between 6 and 8, so the median is 7. Okay? The median does not have to be a number in the set of data. That's important too. The mode is always going to be a number that's in that set, you'll see that number in the set when you find the mode. The median sometimes, like in this case when it was 7, we actually don't see 7 listed anywhere. Well, we actually don't see 7 listed anywhere in this list, but it's still the median. Okay, I'm going to try to keep going. Mean is our average. Okay, so you'll hear the word mean. It actually really means the same thing as average. So this is the sum, means adding, the addition of a set of values divided by. So you take that sum and then you divide it by the number of values in the set. Okay, so the sum of a set of values divided by the number of values in the set. Maybe sounds confusing. We'll go through some examples. Hopefully you get it. So in this, we'll take this same example we initially looked at. So the Oilers scored these goals in 10 games. So what was the mean of the goals scored? So to find the mean, which is another measure of central tendency, sort of finding that middle, finding the average goal scored, we're going to take all of these numbers and add them together. So 5 plus 4 plus 3 plus 2 plus 1 plus 5 plus 3 plus 3 plus 7 plus 3. Okay? We take them, we all add them together. It doesn't matter what order they're in, because we're just adding them. And then that sum, whatever that answer is, we're going to divide it by how many numbers there are. We look at our set, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to divide this by 10. And that's going to give us our mean. So let's add these together. 5 plus 4 is 9, plus 3 is 12, plus 2 is 14, plus 1 is 15, plus 5 is 20, plus 3 is 23, 26, 26 plus 7 is 33, plus 3 is 36. So we get 36, and that's being divided by 10. Can't forget to divide by 10, which equals 3.6. So 3.6 is the mean. So on average, they scored 3.6 goals per game. Again, your mean is not necessarily going to be in your set of numbers, and often it will be a decimal, because you can't actually score 3.6 goals in a game, but that is still the average of the goals scored. So it doesn't even have to be a whole number. Okay, so for example, what is the mean of each of these sets of values? So we have 7, 8, 6, 9, 9, 5, 7, 7, 8, 4. We add them together. Okay? So I'm going to go plus, 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 plus. Add these all together. And then whatever that answer is, that's why I'm just going to put this in brackets, I'm going to divide that answer by how many numbers we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. So we're going to divide by 10. So let's add these together. 7 plus 8 is 15, plus 6 is 21, plus 9 is 30, plus 9 is 39, plus 5 is 44, plus 7 is 51, plus 7 is 58, plus 58 plus 8 is 66. 66 plus 4 is 70. I believe that was right. So we get 70 is the total, which we have to divide by 10, which is how many numbers there were, which is equal to 7. Okay. This other set, we have 1, 2, 3, 4, 5 numbers. We're going to add them all together. You always just add all your numbers together, and then you divide by how many numbers there are. Divided by 1, 2, 3, 4, 5. Okay, so add first, because I have it in brackets. We have to make sure we add that first. 300 plus 250 is 550, plus 400 is 950, plus 300 is 1,250, plus 250 is 1,500. I believe I did that all correctly, and I'm dividing that by 5. Okay, well, 15 divided by 5 is equal to 3. Then I just keep these 2 zeros in. So my answer would be 300. You can also use a calculator. In fact, you will need to use the calculator to find an average, because often your answer could be a number that has many decimal places potentially. Okay, so it is fine if you use a calculator. Our mean is our average, and that's 300. Okay. Key ideas with mean. So to calculate mean, add all of the numbers in the set of data. So just add first and then divide by how many numbers you have. So the number of numbers. So in this case, 4 plus 6 plus 8 plus 10 plus 6 plus 7 plus 15. We divide by 7 because that's how many numbers there are. 1, 2, 3, 4, 5, 6, 7. 56 divided by 7 is 8. So the mean of these numbers is 8. And the mean does not have to be a number in the set of data. Okay, so that's it. You need to know these three and their definitions: median, mode, and mean. You need to know how to find each of those, and that is the main ideas from section 12.1 and 12.2. There will be an assignment on Google Classroom.